Hello everyone. In this video, we are going to explore a newly launched capability in IBM App Connect, one that brings enterprise integration and AI much closer together. We'll look at how you can use IBM App Connect to create an MCP server, define and expose 2,800 plus MCP tools, and then make those tools available to an AI agent so that the agent can securely discover, reason over, and invoke enterprise integrations in real time. I am now on the IBM App Connect dashboard. In the left-hand navigation menu, you can see a new MCP section. To begin, I'll click on Create MCP Server button, which will initiate the process of creating a new MCP server. I'll choose to create a new server and click on Next. I am then prompted to provide information for the MCP server. I'll start by entering a name for the MCP server in the text box. This name will be used to identify the MCP server and the tools it exposes when they are accessed by an AI agent. I now see a list of App Connect connectors listed as MCP tools. Next, I'm going to choose the connectors I want to expose as MCP tools. I'll start by searching for the connectors I need. For this demo, I will choose Slack, Salesforce, and Postgres database. As I select each one, App Connect prompts me to provide the connection details. This is where I configure the credentials and endpoint information so that the MCP server can securely access each application. After completing the connection setup, I can now see each connected application listed. I'll select each app in turn and browse through the available tools. These tools correspond to the actions exposed by the connector. The key point to highlight here is that every single connector action is exposed as a unique MCP tool. This means that each operation, such as sending a Slack message, creating a Salesforce record, or querying a Postgres database, is available to an AI agent as an individual, well-defined capability. With IBM App Connect, this adds up to a powerful catalog of over 2,800 plus connector-based MCP tools, which are available today. After selecting the connectors and completing the connection setup, I've chosen a total of 19 tools across the three applications. With the tool selected, I'll click Next to review and verify all the MCP tools that will be exposed by the server. This review step gives me a clear view of every selected tool before the server is created. Once I've confirmed everything looks correct, I'll click Create MCP Server. At this point, App Connect provisions the MCP server inside one of its integration runtime and makes the selected tools available for use. I can now see the newly created MCP server as a tile on the MCP server dashboard. I'll tap on the MCP server tile to open the server details. Here, I can verify the MCP server URL along with the username and password that an AI agent will use to authenticate and connect to the server. I can also navigate to the MCP Server Tools tab. This allows me to review and verify all the tools that was configured and exposed by this MCP server. Now comes the most interesting part. For the AI agent, I'm using IBM Bob. I've added the MCP server I just created into Bob using the MCP server URL and credentials provided by App Connect. With this configuration in place, Bob can now securely connect to my MCP server. I'll now ask the AI agent questions and allow it to fetch this information directly by invoking the MCP tools exposed by IBM App Connect. As I will interact with Bob, it will no longer rely on its knowledge or reasoning. Instead, it will fetch real-time information and perform actions by calling the tools inside my MCP server. Now let's ask Bob some questions. Fetch all the loan leads from Delhi. What's important here is that I'm not telling Bob which system to query. I'm simply asking for the information I need in natural language. Bob will interpret the request identify the most relevant MCP tool to use, and then invoke it through the MCP server I created in IBM App Connect. I'll ask Bob another question. Fetch all the personal loan leads from Karnataka. And once Bob gives the answer, I'll ask it to send the lead information to the Karnataka team's Slack channel. Let's also verify in Slack what's happening. Here in the Karnataka team Slack channel, I can see the messages that were posted. The loan lead details fetched by Bob from the Postgres database have been successfully sent to this channel. I'll continue by asking Bob a series of additional questions here. First, I'll ask Bob to create a new loan lead and will provide the lead details as part of my request. Bob interprets this request and determines that creating a loan lead maps to an insert operation in the Postgres database. Using the appropriate Postgres MCP tool, Bob then creates a new record with the provided information. To confirm this, I'll switch to the Postgres database and refresh the view. Next, I'll tell Bob that this lead has now been converted into a new loan enrollment. Based on the context, Bob understands that loan enrollments are managed in Salesforce. It selects the relevant Salesforce MCP tool and creates a new loan enrollment record in Salesforce using all the lead information I've provided. To verify the outcome, I'll refresh the Salesforce page, and here I can see that the new loan enrollment record has been created successfully. For the final use case, I'm going to give Bob a much more complex task. I'll ask, fetch all the loan enrollments, transform each of them into a standard format, and then post the information to the general Slack channel. What makes this interesting is that I'm not telling Bob how to do it. I'm just describing the outcome I want, and Bob figures out the steps and the tools required. Bob identifies that loan enrollments are stored in Salesforce, so it invokes the Salesforce MCP tool to retrieve the list of loan enrollments. Next, Bob transforms each enrollment into a consistent and standardized format. After transforming the data, Bob then switches to action mode. It selects the Slack MCP tool and posts the formatted enrollment summaries into the general Slack channel. This is a great demonstration of how IBM App Connect MCP tools allow an AI agent to handle real enterprise workflows end-to-end by combining data retrieval, reasoning, transformation, and actions all through the MCP server.